All right. How is everyone doing? Sorry about such a long timer. That was my bad. I needed a little bit of time, but not that much time. Okay, so we got some breaking news. I have been contemplating this, and so I'm doing it now. You guys let me know how you like it. There are certain large events that happen that feel weird to wait until, Sunday to talk about. And so I'm going to try to do some of these throughout the week whenever there's a large thing that happens that you probably should know about, especially if you run with containers in production. You probably should know about this today. Probably should have done the stream yesterday. So anyways, I will be doing more of these. You guys let me know if you like them or don't like them. So let's talk about it. Yesterday afternoon, about this time, there was a release by Sneak. Sneak they do container scanning, and they released a vulnerability, a slew of vulnerabilities that we're going to talk about. We're going to talk about one more than the others. The others do affect you, but let's talk about this. We're going to talk about first how to release a vulnerability the right way. This, I think, really did incorporate what I love to see about a good vulnerability release. Now, check it out. When Sneak it was just yesterday that they released this to the public. But look at what happened behind the scenes. Let's look at what happened behind the scenes. The week of the 20th of November, 2023, 2 months ago. All right. The initial verification process and proof of concept exploits were being done. Initial disclosures sent with all vulnerabilities, and Docker act the same day. So Docker responded the same day to the vulnerabilities. Now, I'm going to state that this affects more than Docker. So if you're like, oh, phew, I run containerd, or oh, phew, I run cryo, don't stop. Don't stop right yet, because it affects much more than Docker. Docker has some Docker-specific ones in the Moby build kit, but there's one in runc, and runc powers, I think, every major container runtime, whether it's cryo or containerd or whatnot. You might be able to find one. All the ones I know use runc, so don't just stop there. But let's keep going on here. All right. So this is where Docker basically said, this isn't us, it's runc for this one. And we can follow the timeline through here. But the thing is, when it was announced yesterday, observe. Maintainers of runc released 1.1.12, addressing the vulnerabilities. Sneak released the reference implementations. Containerd released version 1.6.28, which contained the updated version. Docker released build kit. This is the Docker specific things. GCP, Ubuntu, and AWS all released an update to their base images, updating to 1.1.12 immediately. I'm looking at you, Azure. As far as I've seen so far, Azure hasn't released a new container runtime. I don't know if they have or haven't. I didn't find it. I did a very quick Google search. Didn't see it. It's not on this list either. And they are updating this with stuff. So actually, let me throw this in chat for you all. Now, this is a very serious issue here. Now, I'm going to say it's very serious for some people, less serious for others. And we'll talk about the differences and who it's more serious for and who it's less serious for. Although you should patch it no matter what. The CVEs, I don't have those open yet. Let's actually pull up the CVEs here. All right. Okay. So runc, to understand what this is, runc is the thing that basically orchestrates with the kernel. And the root of this attack here, and you'll see that there's a couple different ways that this attack can be leveraged, is that there is a a file descriptor that is leaked. So, which basically allows you to get control of the base file system. So if you wanted to put it out this way, run C does this stuff here, manages these namespace, and you have your whole system's namespace. I said system, you could say root namespace here. You have your whole system, and then your containers are given their own namespace. And this is the big protection thing. Okay, so run C sets up C groups and namespaces on the Linux host itself. And in these, your containers get these. What happens here in this is that basically, due to an internal file descriptor leak, the attacker could cause newly spawned container processes to have working directory on the host file system namespace. So instead of being confined to this, basically a leaked file descriptor would give this container some pointer to the system namespace. And the problem with this is if you have the ability to arbitrarily write stuff here, you can leverage that to arbitrarily execute code here as well. And that means that basically, if you pulled a bad container image, your host, they could run arbitrary code. Now, I think the reason this didn't get a 10.0 out of 10, and it didn't even get a 9.5 or a 9.6, it got an 8.6, I believe. I believe 8.6 is the security rating. Wait, my goodness, isn't it like right on? Oh, it's still, NIST is still figuring out. I believe most people are rating it at 8.6, but maybe NIST will come back with what I believe is a deserved 9.5 at least. Anyways, I'm not a professional, so why would I come up with 9.5? That's what I watch a lot of these. I feel like it's a 9, but I believe that the people that were rating it a little bit less there's two reasons. One, the hacker can't initiate it. You have to pull the bad image. That's number one, is it's on you to pull the bad image. So basically how this works, and we'll get into the exploit here. This is actually the exploit code, the demo. How this vulnerability works here is that it's on run and build. It's on run and build. So you have to pull a vulnerable image. You can't attack a vulnerable image. It's not like there's a vulnerable image. You have to pull a dirty, a tainted image. And so as long as this is what you can do. Know what images and what base images you're using. That's like key takeaway number one. If you only used your own internal images, you're fine. Another key takeaway, per their disclosure here, they didn't find any public repos leveraging this. So as of today, there was no one taking advantage of this that they found. They scanned all the common ones. So you're talking about your Debians, the Ubuntus, the blah, blah, blah. None of those had been taken advantage of. So you're also safe there. And so like, this would require you to pull an image from somebody you don't know. Now, who does that? Who does this? And this is probably the biggest deal and the biggest industry that it's going to. Who pulls and runs images that they don't? This is cloud providers. AWS, GCP, Azure. You think of their services like Fargate and things that just run a container for you. These are the things that are vulnerable to this. These are the ones that are, because they're pulling just some random person's image. And this could be a way to escape the safeguards. Now, they have a lot of safeguards, but those are the people that are going to have a lot more issue with this because you don't know. So the Null Cloud is another one. Docker run privilege. Obviously, you can run Docker in privileged mode. The thing is, this gets around that. This gives you privileged without actually giving Docker privilege mode. Like you don't have to give it the permission, the capability. That's what they're called. You don't have to give your container the privilege capability. So this is all in Docker files. So it's actually a order of execution of vulnerability. Let's actually go to the write-up on this. Yeah. So this is an order of execution vulnerability where how the file descriptor wasn't getting cleaned up. And I haven't actually looked into the code of run C for this. So I can't really say that. But this is them showing that they don't get permission denied running it with the tainted container. Anyways, I'll post this link too for you all. All right, now there were a couple other ones, and I know we've been talking about this and the leaked file descriptor, but there are a couple other things which actually Docker Build Cloud was vulnerable to. If you go back to the one with all of them, these were all build kit. So if you use build kit to build, there were actually some other ones. Now, I believe one of these was rated high, and the other two were rated medium. These aren't quite as big of a deal. And they're when you're building one of these bad images where you can basically take over the build machine. That was, I believe, this one, the build kit mount cache race. And then the other two were medium, but go ahead and check them out for yourselves. Anyways, yeah, this is a pretty big deal. So if you're using BuildKit to build, and this was Docker Build, so they have a build service for you where you can build containers in the cloud because that's the thing. They have patched it. You can see that down in their patch notes, Docker released BuildKit and Moby and whatnot. So they have patched that out. So I guess my biggest thing is you guys need to actually update all of these because the thing is there is a reference implementation out now that we're about to go take a deep dive into. Not a deep dive, a quick dive into. So that means it's going to be really easy for people to reverse engineer. But this was actually a really good disclosure because they made sure everybody had time to patch it. They made sure that they coordinated all of these releases. So everything was out when you needed it. So if you haven't, you need to start making plans. I know that I said if you're pulling images, you need to update though. You need to, if you are on Ubuntu, if you're on AWS, you need to go ahead and update because you never know when somebody's going to do a supply chain attack or whatnot to get into that Debian 12 base image or, trick somebody into using that vulnerable image. And as soon as you do, you're going to get owned. So you need to go make sure that you're patched and you need to make sure that, going forward, this is taken care of. All right. And it was a good disclosure. I really love how this worked out. And I know it sounds like a really long time. And it was a really long time, but they got everything in because the thing is, what we're going to go see now, you could implement it now. We can go tomorrow, we can go tonight and implement one of these bad files. So as soon as this is released, nobody else knew about it. And now they do. And now it's easy. So there's two different detectors that Snyk created, which is pretty cool. We have a static detector, which is the one we're going to look at. And then we have the dynamic detector, which this one actually uses eBPF. So I know we always talk about what is it used for. Well, this is what it's another thing that it's used for. So this one actually uses eBPF to try to check for the behavior that they're expecting from a container that's leveraging this exploit, which I think is really cool. And I think that maybe we should do a deep dive on this at some point, but I don't know eBPF nearly well enough. And it's in a lot of C. It's a lot of C and eBPF. So, if you guys want to dive into this one at some point, I am happy to give that a shot. But this is a quick stream of important news that came out. The other one is a static detector that actually looks for the behavior in your Docker file. This one is much easier. It's all written in Go. It doesn't have eBPF. And you can actually be scanning your Docker files right now. the really cool thing is that this actually scans the Docker file and actually scans any from reference. So, if you're doing from Debian 12, it will also scan Debian 12 to the best of its ability, because it just goes through the history of the layers. So there's, again, it's not perfect. It's not perfect, but you can go ahead and do this. And do you guys like these impromptu, spur of the moment, important topics? Let me know. All right, so let's jump into this code. It is Go, but you have this analyze base image here that we could use this to reverse. We're not going to do it today, but I'm kind of interested to reverse engineer a Docker file to actually take to leverage the vulnerability. And okay, so we have the. Oh yeah, I'm done with work. I'm supposed to be eating dinner in about 7 minutes, so I gotta hurry up and finish, or else I'm gonna be in trouble. So there is this command, and there's basically two different ways. There's the auto analyze image, which that's just going to take the layers of the image. So if you have an image on disk, you can do Docker images, and you can use it to scan one of these images that are on disk. Or you can point it at a Docker file. So if you have a Docker file on disk, you can also point it at the Docker file. So those are the two ways to leverage it. And it just has this analyze command, which does these things. So it's actually not that complicated. There's a little bit of jumping around. I'm not sure that I fully understand everything it does at this point. But yeah, so it gets the base images, and then it just calls this auto analyze on it. This is interesting because it has differences between whether it's a Docker hub and the analyze. But yeah, this is all of its analyzing. So it's cool. I think that this is really awesome that we get this code to go about. If you guys would like a stream digging through this code, I would be happy to. I dug through it some today. I didn't have enough time to fully understand it, so I'm not going to sit here and tell you much more than this, because this is about as far as I got. A little bit further than this, but only a little bit, because there's a lot of code here, and it's a little Java-y. This analyze here, which is just just some interface somewhere. It feels a little Java-y to me, but I would be happy to. But I wanted you guys to know, this is out there in the wild. You need to update. Golang in this economy? Yes, Dutch. Anyways, that's going to be it for me for right now. I don't know if I'll stream later tonight. Pretty long day. I hope that you guys like these impromptu little bits of nuggets of really important news that happens. If you do, I'll continue doing them. I'm going to try to analyze them the best that I can before we do them, but I also am not going to wait until I have enough time to have gone really far in depth, because you need to hear about them. So anyways, let me know how you like them, what you'd like me to change about them.